So children, if you remember, last time we were doing these type of questions. These are based on your understanding of the thermochemical equations. So let's review the rules before we start the question again. That if there is a reaction, A is giving you B, and delta H of the reaction is, let's say, minus 280 kilojoules. Just an equation taken from my side. So if I reverse the equation, what happens? What's the delta H of the reaction if I reverse it? What's the delta H naught of the reaction? So answer in the chat. I just reversed it, Dhruv. I didn't multiply it by any factor. Dhruv, I didn't multiply this equation by any factor. I just reversed it. So it will be plus 280 kilojoules per mole, right? Okay. But if I multiply the above equation by 2, what is delta H naught of the reaction? It will be 2 times minus 280 kilojoules. Yes, thank you very much, Sri. Good. Okay. And if I add two equations, like A is giving me B, B is giving me C, delta H naught reaction for the first one, for the first reaction is minus 280 kilojoules. But B to C, delta H naught reaction is plus 200 kilojoules. Two reactions. I've given you two reactions. Very important concept. Let's say the energy needed for reaction 1, this delta H for the first reaction, let's say it is delta H1. Let's say this one is delta H2, right? Now you add these two equations, add them. When you add them, this B and B cancelled. It is the intermediate, you have done unit 5, right? So the final equation, the overall reaction is A to C. We call it as overall reaction or net reaction. So this is the language we will see in the book. So what I'm doing, I'm adding reaction 1 and reaction 2. This is reaction 1. This is reaction 2. I'm adding them. So what happens to delta H of these final reaction? So delta H naught for this final reaction is the sum of these two. Whatever you are doing, you will do the same thing on the enthalpies. You are reversing equation, sign of the enthalpy will reverse. You are multiplying it by a coefficient, enthalpy will get multiplied. You are adding two equations, enthalpies will get added. So what's delta H naught reaction? Minus 280 plus 200. So answer is minus 80 kilojoules. You're understanding this concept? Write down this example and then write this concept, the last one which I have just done, that adding two reactions. You're going to use it in Hess's law. Hess's law. We have some idea about Hess's law in the Born-Haber cycle we did in unit 3 when we were adding all the enthalpies and trying to calculate the delta H naught of the lattice or something like. There were questions based on that Born-Haber cycle in unit 3. That is also based on Hess's law. So can I go to the next slide now? Children, can I go to the next slide? Okay. So I'm going to erase this. Now let's do this question. This is the last question, I think. Last time we could not do this question. It's based on the same concept, that how to calculate delta H naught of the reaction. Can you do it fast, Sushant? Change your name, please. By the time he's writing this, let's start doing this question. This is the reaction. Answer my question. Is this reaction exothermic or endothermic? This reaction is exothermic or endothermic? It is exothermic. How much heat is evolved for the production of 1 mole of water? This heat is for how many moles of water? 2 moles. So you know this. 2 moles of water, when 2 moles of water are formed, liquid water, liquid. See, liquid. The heat released is minus 572 kilojoules. This is the ratio I know from the equation. Now they're asking for 1 mole. So you can start with this 1.00 moles of H2O liquid and plug in this ratio, which you know from balanced equation. How to plug in this ratio? What do you want? How much heat? You want kilojoules. Take it in the numerator. Minus 572 kilojoules over 2 moles of H2O liquid. So what's the answer? The answer is, you just divide this 572 by 2. What is the answer? Minus 286 kilojoules. Right? So this is called a dimensional analysis. So you can use dimensional analysis to calculate the amount of heat evolved. From the equation, you know that for 2 moles of water, this is the amount of heat evolved. So you know this ratio. You can plug in this ratio, right? So we are going to do dimensional for the B part. B part. This is question 46 from your that Zumdal book, which is already there. I don't know the edition. Edition maybe, I think ninth edition maybe. Now it has 11th edition is also there in the market. After every 2 years they change the edition, but there is hardly any change in the questions or in the material. There are no new discoveries in chemistry. So please don't run after editions. Any book, even 5th edition of this Zumdal book is really good and is easily available, very cheap. It's available online also. Anyone in need of the book can always contact me on WhatsApp, okay? So any edition is good. Now let's see the B part. How much heat is evolved when 4.03 grams of hydrogen are reacted with excess of oxygen? So how to do it? Let's do the planning. Look at the equation. What do you know from the equation? That we know that for 2 moles of H2 gas, the amount of heat evolved is minus 572 kilojoules. Now they have given me grams, so Shrihan is right that you are going to convert your 4.03 grams of H2 to moles of H2 to, what are they asking? How much heat? 2 kilojoules. Ready, children? Now we are going to plug in the ratios. Practice this. This is very important. Unit 1. In Unit 1, we did all these mole concepts, dimensional, everything. Unit 0, Unit 1. So let's start with 4.03 grams of H2. Tell me the first ratio. What should I plug in here? And tell me the second ratio. What should I plug in here? It's H2, Shrihan. It's not H. Take care, children. It's H2, not H. So 1 mole of H2 divided by 2.016 grams of H2. Next ratio. Who's going to tell me the next ratio? I want kilojoules, and this is a relation I know from the balanced equation, this relation. So what should I plug in here in the numerator and what should go in the denominator? From the balanced equation, I know the relation between moles and delta H. Any one of you? Dhruv, you're not answering? Yes. But why two? Okay, I think he's trying to say second ratio is minus 572 kilojoules over 2 moles of H2. Now you can see moles of H2 cancelled, and grams H2 cancelled, and you're left with kilojoules. This number has 3 significant figures, so answer will be 3 significant figures, right? So you can give me the answer. Isabella, you're understanding everything? Please answer here, all of you. Now let's see the C part. How much heat is evolved? Again, they're asking heat. When 186 grams of oxygen is reacted with excess of hydrogen. So who is going to help me with the C part? How to start? And what do you know from the balanced equation? From the balanced equation, what do you know? The way I was telling you what we know from the balanced equation, if you see, I was telling you this thing. Moles of water related to kilojoules, moles of hydrogen related to kilojoules. So what I know for the C part about oxygen and kilojoules, I know that 1 mole of O2 is going to release minus 572 kilojoules of energy. Yes, this ratio you know. Children, this is something which I have seen children. Students are generally confused. 1 mole of O2, 2 kilojoules. This is dimensional. I'm using balanced equation. I'm trying to set up the relationship. Practice it. It's very important. Now, how to start? What is given? Start with what is given. What is given? 186 grams of O2. You will go from grams of O2 to grams of O2 to gram has to be converted into moles always. Moles of O2. Why? Because equations are in moles. These equations are in moles. So definitely if gram is given and if I want to check the relationship, I have to convert that into moles. And from moles of O2, I can get kilojoules by using this ratio. Ready? Let's set up the ratio. We are doing C part, children. So 186 grams of O2 times, tell me the first ratio. Tell me the second ratio. Very good. 1 mole of O2 over 32 grams. Don't take 16 grams. It's O2, it's not O. Then minus 572 kilojoules, second ratio from here, over 1 mole of O2. This ratio I have taken from balanced equation. Solve it. Go for three significant figure because starting number what is given is in three significant. Rest all are ratios. Right? And that will be the answer. So we are good with the C part? Yes, yes. So children, I hope all of you have this calculator which Shrihan is writing, TI-84 plus. That graphing calculator. And you know that graphing calculators are permitted from last year. They have just permitted last year only the first time the children were using it. So graphing calculators are going to help you doing questions very fast. Straight away you can plug in everything. Is it graphing calculator, Isabella? Yeah, yeah. Any graphing calculator is permitted. Any company. They will not tell you use exactly this company, use exactly this type. They are saying graphing calculators are permitted. That's it. Yes, you can use it every time. You can use it in earlier in the free response only calculators were permitted earlier. Only during free response calculators were given to the students. But now they have said you can use it in multiple choice questions as well as free response and graphing calculators. It's a big thing. Means they are going to reduce the time for solving question. Earlier they used to give 2-3 minutes for one question. This I think now they have reduced it to 1 minute for MCQ. So that is the reason I'm after you. Please start using it. Don't think that, oh, I'll take my graphing calculator and do it on that day only. No, it needs practice. You will do errors in plugging in the values. My other students, other group children, they have started using it and they are doing plenty of errors. And I cannot teach you how to use it because I don't have. So my request is watch some videos, online videos, YouTube videos to understand how to use it and start practicing using in this class only. Okay, so this is C. We are done with C. Did you get the answer? How many sig fig you are going to put your answer, Shrihan? Only 3. So it will be 3320. Yeah. And minus is exothermic kilojoules. Or you can say minus 3.32 times 10 raised to power 3. You can write like this also. Okay, now we are doing the D part, children. D part. Read the question and help me. Let me see. This is a combination of Unit 3 and Unit 6 question. You must have heard about Hindenburg. Anyone knows about Hindenburg in Germany? It was a plane. You know, in this Hindenburg, they were using hydrogen gas as a fuel. And hydrogen gas is very explosive. I don't know why they were using that because it's very light, highly flammable, and it's very light gas. So that's why they were using it. It's very light. It gives large amount of energy on combustion. But this hydrogen gas combines with oxygen and the reaction is very fast to give you very stable product. What's the product? It gives you very stable product. That's why the reaction is very fast. One of the most stable product around you. Ah, Shriya, no. Hydrogen gas on combustion gives you water. Hydrogen always on combustion gives us water. Water is one of the stable product. This is the reaction for D part. It's the combustion of hydrogen gas. So this Hindenburg aeroplane, the plane was using hydrogen gas as a fuel, which can undergo combustion with air. In the air, oxygen of the air, not with nitrogen, right? Oxygen of the air to give H2O liquid. Reaction is highly exothermic, so a large amount of heat is released. And if this hydrogen gas is undergoing uncontrolled combustion, that's what's happened with Hindenburg. It exploded in the air. It was about to land. So all the media people in Germany, cameras, media, everybody was there to welcome the people who were there inside the plane. And just before landing, it exploded in the air. So after that, I don't think anybody has used hydrogen gas as a fuel in aeroplanes. No, you cannot. You cannot use it even in your houses. There's no, we don't use hydrogen gas cylinders in the houses. No, because it's very risky, because it's highly combustible. Okay, now this is the reaction, right? The total volume of hydrogen gas needed to fill the Hindenburg was this. Volume is given. I'm making the list of the things which are given. It's a combination of unit 6 and 3 question. Free response question type. How much heat was evolved? Oh, heat. They're asking delta H. How much heat? Assuming all the hydrogen gas reacted. That's it. They have given the volume and they are saying all the hydrogen gases reacted. They have given the temperature. They have given the pressure of hydrogen gas. See, I missed this thing. These two are also given. How much is the temperature? Temperature has to be in Kelvin. 298 Kelvin. You know how to do it, all of you? And the pressure is? How much is the pressure? 1 atm. These are the things given. What else is given? Balanced equation. This one. I know delta H of the reaction. See? So I know that one more thing is given. I know that 2 moles of H2 on combustion gives you minus 572 kilojoules of energy. I know this from the balanced equation, right? Equation. Why? What is written here? Shriyan is asking how come you know this reaction? What is written here? Hindenburg exploded. Hydrogen gas. Hindenburg exploded. A combustion reaction of hydrogen with oxygen. We have done so many combustion reactions in unit 1. Empirical formulas, molecular formulas. There we did plenty of combustion analysis. You go and check that video. And there I told you the meaning of the combustion reaction. Combustion means burning in the presence of oxygen. So hydrogen gas is burning in the presence of oxygen. So this is the reaction. This one, right? Okay. Now how to start? I need moles of O2. So do you think this information can give me moles of O2? The temperature, the volume, the pressure of the hydrogen gas? Yes, I know this equation, PV equals to nRT. What I want? Moles, because I know this ratio. I want moles of hydrogen. I want this. Isolated, N equals to PV over RT. What is P? 1 atm given in the question. 1.0 atm, two significant figures. Volume 2.0 times 10 raised to power 8 liters, two significant figures. Liter is the ideal unit. ATM is also ideal. Temperature 298 Kelvin, three significant figures. This is liter, this is ATM. So what's the value of R? Value of R will be given to you in the question paper. But they will give you two values of R. One value they will give you this 0.0821 liter ATM per mole Kelvin. Another R value they can give you like this 8.314 joules per mole Kelvin. Remember this you were using in Arrhenius equation. ln K is minus EA over RT plus ln A naught. ln A, sorry, not A naught, ln A only. So this R is this value because here you're dealing with energies. But over here in this equation, I'm dealing with pressure, volume, temperature. Units are compatible with this one. So I'll use this. Plug in that value 0.0821. You can see the units, all the units will cancel out and you will be left with moles. Kelvin, Kelvin cancelled, liter, liter cancelled, ATM, ATM cancelled, and we are left with moles. So I know the moles of hydrogen. Yes. How many sig fig for the answer? Get the moles of hydrogen and get the right sig fig. We are doing it. Waiting for the answer. Please take out your calculators, plug in the values, start practicing using your calculator. Mhm. You have to plug in these values. That's it. We are calculating moles of hydrogens up to two significant figures. I'm using ideal gas law to know the moles of hydrogen. Dhruv, are you doing it? I hope all of you are doing it. Arana, what's the answer? And please remember, this number has to be in parentheses. You multiply 1 with 2 times this. But when you put division, after that, put this in parentheses. Okay. Arana is giving me different answer. Dhruv is giving me different answer. Let's wait. And Arana, two significant figures. You will get a very big answer because you are dealing with an aeroplane with hydrogen gas. There is plenty and plenty of hydrogen gas. So definitely moles will be very big number. Anyone else confirming the answer? Ashita, you're doing it? I think, Dhruv, you are wrong. I'm getting the same answer as Arhana is getting. Yeah, others are also confirming the same. If you put this answer in two significant figures, then Ashita and Saranya has given very good answer. Who gave that answer? 2.5. Somebody gave me the answer 2.5. 10 raised to power 9. Okay, fine, no problem. 8.2 times 10 raised to power 6 moles, right? So we do have the moles of hydrogen and we know this ratio. This ratio. So now you plug in to know the heat evolved, amount of heat liberated during explosion of the Hindenburg is, you can watch the video of explosion of Hindenburg in the air. It's there on Wikipedia. It's a very popular event. Of course, it was not a good thing, unfortunate incident, but it's a big chemistry. Check the video. Hindenburg exploded in the air. Heat evolved is 8.2 times 10 raised to power 6 moles. Then plug in this ratio. Minus 572 kilojoules over 2 moles of H2. Your answer should be in two significant figures, this one. And that is the final answer. And you'll see this is a very large amount of energy. And with this explosion, most of the people, they died. But I think some of them survived because it was about to land. I don't remember exactly what happened. But yes, it's a large amount of heat. So are we okay with this question? This is the what we have done. Thermochemical equations applications. Like if you how to convert moles to joules, how to convert grams to joules, like this. Shrihan is giving us answer. Can you put it in scientific notation with two significant figures? Shrihan. Scientific notation with two significant figures. And I just want to give you one more question from my side. It's not there on this slide, so I'll make a question from my side and you have to answer that question. So shall I erase it? I'm sure that you can do the calculation now. Is this right answer? What are the units, Shrihan? Units. You are giving me a number without units. Units. Kilojoules. Yeah. Just write kilojoules. Yeah. Okay, fine. Yeah, good. Okay, ready for one question from my side? E part. Question is, how many grams of water, liquid water, are formed on release of this much amount of energy? Can you see the question is asking you to convert this kilojoules to grams of water? Now, what do you know from the balanced equation? You know that 2 moles of water are formed, right? By the release of this much amount of energy. Now, what is given? Start with that. Given is this. So, I will start with the energy now. I convert this kilojoules to moles of water using this ratio. Moles of water. And then I convert these moles of water to grams of water. So, are you ready to help me? Sorry. Okay, good. So let's start. Minus 1144 kilojoules times first ratio. Tell me the ratio. What should I plug in here and here? Yes, this time I'm going to take moles of water in the numerator because I want moles of water. In the denominator, it will be minus 572 kilojoules. Second ratio. Give me the second ratio now. I want grams of water. I have this kilojoule cancelled. I have moles of water. So, yes, 18.0, I think 2 of water divided by 1 mole of water. I use the periodic table, the molar mass concept here. And the answer will have 1, 2, 3, 4. 4 significant figures. You are going to decide sigfig from what is given to you, not from these ratios, okay? This number will tell you sigfig, so 4. And that will be the answer. And the units will be, you see, minus minus cancelled. Units will be grams of H2O liquid because rest all are cancelling. This minus minus will also get cancelled. It will become plus. Is this question clear? So this is dimensional. They can give you amount of energy released and they can ask you how much water formed, how much oxygen needed, how much hydrogen needed, like this. Anything they can ask. And then you can use this balanced equation to convert kilojoules to moles, moles to grams. So this is called as planning. Any questions? Isabella, you're getting it? I hope all of you are here because I'm getting very less answers. Sanjana, Saranya, Siri, everything is okay? Okay, good. Ready for next topic, children now? Oh, there is one more. This is quite interesting question. Yes, Shrihan. Let's see this question 49, this one. It's a physical change, right? Liquid to gas, no change in chemical composition, temperature given, pressure given, delta H is more positive than delta E. Now, do you remember delta H and delta E and W? What's the relation between delta E? Delta H is the form of Q, right? Heat. Do you remember the relation, any one of you? Delta E is the very first topic we started last week with the sign convention and everything. Delta E is Q plus W. Yes, this Q is delta H, children. This is the heat measured at constant pressure. I'll explain you more about it. Heat measured at constant pressure. That is delta H. Enthalpy change. So now in this question, so I can write this equation like this. Delta E is QP plus W. I can write it like this. I can write it like this. Delta E is delta H plus W. Ready to answer this question now? Yes. Let's say delta H of the reaction is X kilojoules. What is delta E of the reaction? Read the question carefully. Delta H is more positive than delta E. So what is delta E? It is X kilojoules minus 2.5 kilojoules. Can I say that? See, they have written. Now plug in these two values here. So X minus 2.5 kilojoules is X plus W. X and X cancelled. So W is minus 2.5 kilojoules. Yes, children. Is it troubling question or is it okay? We know this equation, right? We are okay with this equation. They have said delta H is more positive than delta E. If I take my delta H as X, delta E is X minus 2.5. Now, what does the quantity represent? That's the question. So what is it representing? Question is asking, what does this quantity represents? You have done it. What is W? It represents work. It represents work. Work done on the system or work done by the system? See the sign, negative sign. So is it work done on the system or by the system? Yes, Shrihan, it is the work. This quantity represents work done by the system because it has a negative sign. Anything with the negative sign means energy is going out of the system. Is this question interesting? Okay, moving on. Okay, now we have done one part of this unit 6. Understanding of heat, Q, W, endothermic, exothermic, energy profiles. I think I explained you the energy profile also. If I give you some reaction like this reaction is endothermic, exothermic. Energy profile. This is reactant, product. Answer few questions. Is product more stable or less stable than reactant? Product is more stable or less stable? It is less stable. You know the reason? Siri, what's the reason? Because it has high energy. And there is a mantra in chemistry, more attraction, less energy, more stable. It means in the product, the bonds are not very attracted. In the reactant, attraction is more. The bonds are more stronger. You can say reactants have more stronger bonds than the product. More stronger attraction in the reactant, right? So we'll do more about energy profile. I'll share some more diagrams. But now we are on the second part of the unit 6. Here you're going to learn about how to calculate delta H of the reaction. What are the different ways which we are using to calculate delta H of the reaction? These three ways, three methods are based on data. Means data will be given to you, information will be given to you, and from that information you are calculating delta H of the reaction. These three, 1, 2, 3. But the last method is experimental. You have to perform an experiment. You have to do an experiment. And from that experiment, you are going to collect data. Collect data. Data is after the experiment. From that data, you are going to calculate delta H. You're going to calculate delta H of the reaction. Okay, this is completely experimental. Cup calorimeter and bomb calorimeter. Experimental. This is completely theoretical. So I'm planning to finish these 1, 2, 3 today because it's just theoretical. We are going to do plenty of questions. So please understand everything. Hess's law is very simple also. Okay, ready? So method for the calculation of delta H of the reaction. So first of all, let's see what's the meaning of delta H of the reaction. If there is a reaction A to B and here is the heat, then it means reaction is endo-exo. This reaction is endo-exo. It is exothermic. The energy profile is like this. Here is the energy. Here is the progress of reaction, right? Now, this is the reactant. This is the product. Who is more stable, the reactant or the product? Answer my question. The product is more stable. Which one has stronger chemical bonds? Which one has stronger chemical bonds? Bond is attraction. So which one has stronger attraction? Product. In which case it is easy to break the bonds in reactants or products? Easy to break the bonds. In which case? Reactants. What is this energy called as? This one. What is this energy called as? Energy needed to break the bonds, right? Energy needed to break the bonds of the reactant. And what is this called as? This one? This one? Energy? This one? Sanjana, this red one. Energy needed or released? Released, yes. It's going down, it's released. Now, in this energy profile, what is more? Released is more or needed is more? Released is more. The difference between these two energies is called as delta H of the reaction. You will use bond enthalpy. See this one? This is called a delta H of the reaction. But in the energy profile, I can see this is the energy of the reactant and this is the energy of the product. So delta H of the reaction is HP minus HR. So we are going to use this equation in question 2. Not question 2, is the topic 2, this one. We are going to use this equation there. We are going to use bond enthalpies in this topic 3. But most interesting is Hess's law. Here we are going to calculate delta H of the reaction using different types of reactions. 3, 4 reactions are given to you and their enthalpies are given. Delta H reactions are given and you are going to combine these reactions with to get the desired equation. So very interesting topic, very simple, very, very simple. Ready with your pen, paper and calculator. The mathematics is also very simple. Addition, subtraction, multiplication. That's it. No complicated equation, no exponential, no raised to powers. Take care of sig fig. Okay, so first thing, as I said that these are new things for you, but they are very simple. So work with me. Try to understand, answer my questions, try to learn right away. Okay, let's see. The very first definition is standard enthalpy of formation. What is the meaning? So first thing, standard. Standard means standard conditions. So whenever you see delta H with a knot on the top here, this means we are doing experiment or we are collecting data at standard conditions. This is not STP. Do you remember STP, children, from gas laws? This is not STP. This is standard condition. There is a difference. Some children, they take both the things same. No. Standard conditions, generally all the experiments are done at standard conditions. Delta H naught means when the temperature is room temperature, that is 25 degrees Celsius. And pressure is the atmospheric pressure, normal pressure on your head right now, whatever is the pressure, 1 atm. This is standard conditions. Generally, all the experiments are done at standard conditions. You're going to measure delta H naught, delta G naught, delta S naught, E naught cell, unit 9. So whenever you see this naught, then it means they are saying standard conditions. They're applied on solid, liquid, gases, any experiment, they're applied everywhere. But STP, this one, is only for gases. And these are different conditions. Do you remember the condition, STP gas conditions? Any one of you? What do you remember about STP? hmm STP. What's the temperature in STP? Yes, children? Temperature in STP. What's the pressure in STP? STP, standard temperature pressure conditions for gases. Come on. We did plenty of questions on STP in unit 3. Oh, no. Can you memorize it right away, all of you? Right away. Temperature is 273 Kelvin. That is 0 degrees Celsius. This we have done earlier. Or 0 degrees Celsius. Memorize it right away. Pressure is 1 atm. And for 1 mole of gas, we did plenty of questions on this. 1 mole of gas, the volume will be 22.4 liters. Can you write on this right now? 1 mole of any gas at STP is 22.4 liters. That's called as molar volume. Molar volume of a gas at STP. Molar volume. And we did questions. This is one of the most important concept for AP. Okay, can you write down STP conditions, children? Can you type it without looking in your notebook and at the whiteboard? All of you, please type what meaning of STP condition. You can do error in standard conditions, no problem, because you are not using it in any calculations. But STP conditions, you cannot do error. You need to know it because you will be using it in calculations. So all of you, please type STP condition. Something is missing, Dhruv. Can you talk about relation between mole and volume at STP? Yes. And remember, this is for, this is only for gases. This is not for solids and liquids. Isabella, STP condition. Yeah, good. I'm waiting answer from 22.4 liter is what, Sanjana? 22.4 liter represents the volume of 1 mole of gas. Yes. Ashita, good. Good, Arana. I hope everyone has answered. Lasya? Okay. So memorize it right now. Okay. So standard conditions are different, STP conditions are different. So here this all the enthalpies will be defined under standard conditions. So we are dealing with the very first definition, standard enthalpy of formation. Very first definition. So according to this definition, that when a compound is formed, like for example, can you give me example of one compound, any one of you? Let's say Lasya, can you give me the formula of one compound, any compound, compounds, ionic compound or molecules, anything? Yes, Lasya, any molecule or compound, ionic compound or covalent molecule? We'll try to understand enthalpy of formation on that particular example. Lasya giving us? Pick up anything, any compound you are learning chemistry. Okay, Dhruv, Ashita, any one of you? Let's see, whatever comes first. Okay, NaCl. NaCl is first. NH4 plus, not NH4. Okay, good. Let's work with NaCl. Okay, so according to this definition, if NaCl is a compound under standard conditions, NaCl is solid, right? So this is the formation of this NaCl solid from its elements. What are the elements in NaCl? Na. Solid. Under standard condition, it is solid. It's a metal, right? And what else is there? Cl. But Cl does not exist as Cl. So in the elemental form, what is the form of Cl? Elemental form. You remember diatomic gases from the periodic table? Yes, it is Cl2 gas. Formation of 1 mole of the NaCl means take half. This particular reaction, when I write this reaction, whatever enthalpy changes are there, heat changes are there, that is called as delta H naught formation of this compound. And this will be given to you in the exam. Formation values will be given to you. You're getting it? Now somebody type calcium carbonate. Ready for calcium carbonate, children? Calcium carbonate. That's the compound we are forming. So what is the states? Is it solid, liquid or gas? And remember, all ionic compounds are solid. Shrihan. And it is a solid, right? It's an ionic compound. You can see metal with non-metals. So under standard condition, all ionic compounds are solid. Now what are the elements here? Identify the elements. What are the elements? Calcium. Under normal condition, calcium is solid or liquid or gas? Calcium is solid. All metals are solid under standard conditions except, do you remember that except metal? The one which is not solid, which is liquid under standard condition? Metal. Shrihan, metal. Bromine is not metal. The metal which is liquid under standard condition is mercury. Standard condition means 25 degrees Celsius temperature. So only mercury is liquid at this temperature. Okay. What is the other element? Carbon. The standard form of carbon is taken as graphite. Carbon has many allotropes. One of them is diamond. That is also carbon, diamond. But the standard is this, graphite. Stable and standard. What else is there? What else? So is it O3, O or O2? What is the standard form of oxygen? Standard form of oxygen. Standard means stable form. Yes. The way they occur in nature. They occur in nature as O2, not as O3. You don't have O3 around you. O3 is only at very low temperature on the top layer somewhere, right? So this is gas. Balance the equation to get 1 mole of CaCO3. Balance the equation for 1 mole. Calcium is okay, carbon is okay. So you can put 3/2 here. Then oxygens are okay. Yes, very good. Very good, Shriyan. So this is the formation of CaCO3. Then one, I think Dhruv said NH3. He said NH4 plus, but that's an ion. I'm talking about molecules and compound. So let's take NH3. Any one of you know the name of this NH3? It's a very big compound. It's going to make you learn chemistry very well. Yeah, ammonia. It is the one compound we are going to learn many concepts on it in unit 8 and unit 7. Okay, so let's talk about ammonia. Formation of ammonia gas. Ammonia is a gas, right? Under normal condition. This information they will give you. But what are the elements in it? And what should be here on the reactant side? Check the elements. Nitrogen. What's the formula of nitrogen? What should I write? N or N2? N2, not N. And it's a gas under normal condition. Plus H or H2? Yes, H2. Balance the equation. 1/2, right? And 3/2. For the 1 mole, by definition, 1 mole. So these are the delta H naught formation equations. The enthalpy changes. F means formation. It should be F here. This indicates formation. If I write something like this, delta H naught COMB, what does it mean? Combustion reaction. If I write like this, delta H naught SUB, sublimation. The top one is combustion. So they represent delta H of the reaction or the change by writing the name of that particular category of that particular reaction. Combustion reaction, they will write combustion here. Sublimation, vaporization. We are using these terms earlier. We used all of them. Delta H naught of fusion. Fusion means melting. This is melting. Delta H naught of neutralization. Neutralization reaction. So the names are representing what type of reaction or change this particular enthalpy is representing. So they will put it as a subscript on the right side. Delta H subscript right side. So we are okay. But when you see these equations, when you are making a compound from its elements in their standard form, that is called as formation enthalpies. Right? Now here in the delta H naught formation enthalpy, we have decided, this is a kind of what you can say assumption. This is decided by the scientist that the standard elements, standard elemental form like this, all these are standard elements under standard conditions. Their enthalpies are taken as zero. Na solid, zero. Cl2 gas, zero. Why? Because they are standard elemental form in the stable form. So we put it as our the lowest mark of energy, zero. Standard elemental forms are with zero. You can see that carbon graphite, zero. Carbon diamond, not zero. Why? Because it is more unstable than graphite. Diamond is diamond has high energy. You know, you can read in the books all diamonds in the world, all diamonds in the world are getting converted into graphite slowly. Whatever diamond we have in this world, it will take many, many years, millions and millions, but they all will become graphite finally. As we are getting new diamonds formed, as they formed, slowly, very slowly, the time taken is very large. So don't worry, the diamonds in your ears, in your rings will not become graphite in your lifetime. That's because of the structure. Dhruv, Dhruv is asking a very good question. The diamonds are very hard. They are the hardest substance. They have very high melting points. If you remember the structure, each carbon is tetrahedrally bonded to four carbons in diamond, unit 3. But in each carbon bonded to four. Now this carbon is also covalent network. You remember covalent network. And the same thing is there in graphite. Graphite is also covalent network. But in graphite, each carbon is bonded to only three. And then there is one electron here on every carbon because carbon has four valence electrons. But out of four is making only three bonds. So one is free. Now this free electron is delocalized. And this delocalization of this electron is responsible for its stability. There is a big electron cloud because every carbon has one electron, and that electron is not localized, it's delocalized, it's moving like in resonance. So it's moving, and that's why graphite is soft, slippery because of its structure. So please review that. So, Dhruv, I think I answered your question. Okay. So diamond is not considered as standard form. Graphite is considered as standard form. O2 is not, O3 is not considered standard form because it has energy. See, O2 is considered as standard form. So that's the delta H naught formation concept. So enthalpies of pure elements in their standard form is taken as zero. That I already explained to you. This is the table. And I'm highlighting all the standard elemental form. And you can see all of them are zero. Br2 liquid is zero. Br2 gas is not zero. Because under standard condition, bromine is liquid. Br2. See, graphite is zero. Calcium solid. Chlorine gas. Copper solid. See, all these are zero. Because they are in their standard elemental forms. S rhombic is zero. Now rhombic, monoclinic, just like carbon has graphite and diamond with different structures. Sulfur also exists in two different structures. One is rhombic, rhombohedral. Other one has this monoclinic units. But out of rhombohedral and monoclinic, rhombic is more stable. So rhombic is 0. You need not to memorize all these things, okay? But yes, you should know for the simple compounds, pure elemental like O2, N2, you should know that uh, their delta H naught formation values are 0. Right? See, I2 solid. I2 exists in solid form. I2 is not liquid or gas, it's solid under standard conditions. Mercury, liquid under standard condition. All these values are standard enthalpies. We are clear about it, children? Any questions from here? Isabella, you are there? Okay, good. So, ready to move for different types of questions on delta H naught formation. We are going to use these values to calculate delta H of the reaction. You already know, children, that delta H of the reaction, I just explained you the delta H naught of the reaction, naught means standard, is enthalpy standard of the products minus enthalpy of the reactants. The simple equation we know from the energy profile. But if I have two reactants and two products, then with different moles, C, C, D, D, if you see these values are kilojoules per mole, then delta H naught of the reaction is summation. Summation means you are going to add enthalpies of formation of this C. C can be any compound. Multiplied by its coefficient, this C, because these values are per mole. If they are C moles, I'll multiply it. Plus D, delta H naught formation of D. Put it in parentheses. Add them. This is product. Summation of enthalpies of the products with their coefficients minus reactants. But now you have to put them in parentheses because they are two reactants. So A times delta H naught formation of A formation of A plus B times delta H naught formation of B. Close the parenthesis. So that will give you delta H naught of the reaction. Means summation of the products multiplied by their coefficients minus summation of the reactants multiplied by their coefficient. This is the simple equation. We'll use this equation to calculate delta H naught of different reactions. Ready? Ready for first question, children? Okay. Based on this concept, I'm writing an equation here. Values are here. Values will be given to you in the exam. Calcium carbonate solid undergoing decomposition to give you calcium oxide solid plus carbon dioxide gas. Calculate delta H naught reaction using formation enthalpies. Calcium carbonate here, calcium oxide here, carbon dioxide here. Ready? So, delta H naught reaction is summation of delta H naught formation of calcium carbonate. And this is, oh, sorry, calcium oxide, the products, not carbonate, oxide. And this is 1. Put parentheses because there are 2 of them. Plus delta H naught formation of CO2, right? This is of the products, these products. Values are here, they will be given. Minus delta H naught formation of CaCO3. Plug in the values from the table. So calcium oxide is this, minus 635.6, and CO2 is this, plus minus 393.5. So this is of the products. Minus reactants. Reactant is only one, calcium carbonate, and its value is given here, minus 1206.9. This is reactant. And this will give you delta H of the reaction, and you will come to know whether the reaction is exothermic or endothermic, depending upon the sign. Can you solve it? Is it plus or minus? You know, it's a decomposition reaction, breaking down, decomposition. Generally, all decomposition reactions, generally, I'm not saying all of them, but in general, maybe 95%, we can say, generally all decomposition reactions are endothermic. Heat is needed to break. Only Dhruv is answering. Okay, I'm giving you another equation. Use the same method. Table is here, and you are going to tell me delta H naught of the reaction. SO2, which is a gas, reacting with O2, which is also a gas, giving you SO3, which is a gas. I need to balance the equation. So if I take 2SO2 and 2SO3, now this is balanced equation. Calculate delta H of the reaction. I want answer from all of you using the formation values. O2 value will not be given to you in the exam. In the exam, they will not tell you what is delta H naught formation of O2. That you are supposed to know. It's pure elemental form, 0. Ready? Use this equation and give the value. Waiting for the answer. So this reaction is exothermic. And what can I call this reaction? What is the other name of this reaction? See, you're using O2. It's combustion. And combustion reactions are exothermic. Generally, all combustion reactions are exothermic, right? So we are clear about these type of questions. Shireen is writing per mole, but Shireen is of 2 mole. So you don't write per mole. Just write delta H reaction because this is 2 moles. If you're writing per mole, then per mole of what? Only O2. But for SO3 is not per mole. That is for 2 moles. So you write per mole of O2. So that's why we generally simply write kilojoules, because it is per mole for O2, but for SO3 it is 2 moles, for SO2 it is 2 moles. So is this concept clear? Using delta H naught reactions, formations. You know the definition of formation now. To calculate, so these questions are there in free response. To calculate delta H naught reaction. So mathematically they can do anything. Like they can give you an equation, they will give you delta H naught reaction, and they will ask you delta H naught formation value for one of the reactant or product. Like here you are calculating delta H naught reaction when all these values are given. But in some questions, they will give you this delta H naught reaction. They will give you this. And they will ask you what's the delta H naught formation value of SO3. So then you are going to use the same equation. Mathematically, you can assume it as X. Then you are going to put it as X here and solve for X because you know this value. So then mathematically, they can give twist to this question in any manner. Okay. Now we are with the Hess's law. This is one of the most important topic, and this is based on the nature of enthalpy. That enthalpy is a state function. I think I told you the meaning of state function in the last class. Mhm. That's the state function. Any one of you? Remember I said delta H, delta E, delta G, delta S. These you are going to learn in unit 9. Yeah. Delta H, delta E, we have started learning already. These are state functions. Yes, independent of path. Sanjana, very good. Dhruv, very good. They depend only on initial and final. So you're calculating them only by HP minus HR. Product is final. R is initial. Or delta E you can calculate, delta G you can calculate GP minus GR. Delta S you can calculate SP minus SR. These are path independent function. They don't depend on path, right? Path independent. Yes. So all of you, please type what is the meaning of state functions. State functions are, all of you please, just for memorizing. More you speak, more you write, more you learn, more you retain the things. Those who are not answering here, may I request them to type here what is a state function? It is, state function is a, Srayu has written such a beautiful word. See, she has included everything. It depends only on initial and final, and it doesn't depend on the path. Path may be same or not same. Independent on path that they take. Yes. Try to understand and write, okay? Good. So whenever you are going to deal with these state functions, you are free to use Hess's law. I'm going to use Hess's law in all of them. This example you have already done one. You remember one question, we were calculating delta E, step 1, step 2. We added both the steps to know the final answer, right? So here also, now we are going to use the same thing on delta H, Hess's law. Then in unit 9, the same Hess's law will appear again. Then you're going to use it on delta G and delta S, right? So I'm going to clear it. So let's calculate delta enthalpy of formation of this CS2 liquid using Hess's law. Before you start, let's try to understand what we are going to do here. Let's say there is a reaction, reactant A. I need some space, so I'm taking you on the whiteboard. We are working with Hess's law, which is based on state function nature of the enthalpy. According to this state function nature, if there is a reaction which is carried out in different by different path, A to B, that's the B is the product, A is the reactant. This is one path, delta H naught reaction. This is the reaction by one path, right? Means one step, one step. If I ask you to write down the energy profile for this step, it has only one transition state, right? This is A, this is B. It has only one transition state. This indicates only one step. But I am carrying out this reaction now by a different path. I converted this into C and then into B. Then energy of A and B is not going to change. Only thing is that now it has an intermediate. Can you see? This is C here. But A and B are still there. No change. Final minus initial. Because it's path independent. Right? Now I'm carrying out this reaction by a different path. I converted A to D, D to E, then E to B. Now I'm carrying out this reaction in 3 steps. This is 2 steps. This is 3 steps. And this is 1 step. 3 steps means 2 intermediates, 3 transition state. Check here. I'm making it 3 steps. Maybe this diagram is too small. So let's do it again. Step 1, A is here, B is here, uh, B is here. This is A, this is B. Here is the energy. Here is the progress of reaction. Here is the energy. Energy profile. A to B single step. What is delta H? This is delta H reaction. This one, right? This is step 1, single step, 1 transition state. Bond breaking, bond formation. This one. Now making for formation of C, through C, this 2 steps. Can be like this. There are 2 transition state. But finally, the energy of A and B are still the same. No change in delta H of the reaction. Delta H is still the same. Now let's see these 3 steps. 3 steps means 3 transition states. But delta H of the reaction is still the same. This indicates that delta H is a state function independent of path. There will be no change in delta H of the reaction. So how to use this concept? Let's say this is delta H not 1, delta H not 2, delta H not 3. This one is delta H not 4, this is delta H not 5. If I add these reactions A to D, D to E, and E to A, into E to B, this one. I hope all of you are listening. I'm going on this path. Then this is delta H1, delta H2, not means standard conditions, delta H naught 3. Add these equations. Can you give me what's the final equation? And that final equation is delta H naught reaction is equal to what? Add these, all of them. This is intermediate. This is intermediate. You can see here. This is D. This is E. Two intermediates. What's the final equation, children? A to B. I added all these equations. That's the desired, that's the equation you want. See here, that's the equation we are looking up. A to B, delta H naught reaction is delta H naught 1 plus delta H naught 2 plus delta H naught 3. Isn't it? When you add all these values, you'll get the same answer as you are getting here because there is no change in delta H. It's the HP minus HA, HB minus HA. That's going to be same. Whatever path you follow, it doesn't matter. Now this is the path with 3 steps. Now let's see with 2 steps. 2 steps is this one, this one. Let's write down the equations. It is A to C and C to B. Delta H naught 4, delta H naught 5. Add these reactions. Yes, C is the intermediate Cheyenne. Very good. Final equation is still the same. Path is different. What is delta H naught of the reaction? This reaction is delta H naught 4 plus delta H naught 5. So can I say that whether I calculate delta H naught of the reaction by this method or by this method or just by single step, I'll get the same answer. Means delta H naught of the reaction is delta H naught 1 plus delta H naught 2 plus delta H naught 3 is also equal to delta H naught 4 plus delta H naught 5. Can I say that? And this is the concept, children, you are going to use on Hess in the form of Hess's law. This is Hess's law, independent of the path. You just add all the steps, do the changes, add all the steps to get your desired equation. So I'll be using this word desired equation. Desired equation means the reaction which you want. Like here, my desired reaction is A to B. This is my desired reaction. I want to calculate delta H naught reaction for this desired equation. Ready, children? For using Hess's law now? I want you to draw this diagram because you cannot see this diagram in books. This diagram is clearly telling you that delta H is independent of path. Can we go on questions now? I want all of you to be very, very alert, and please do the quiz based on Hess's law. You can do the quiz just after the class if you want. And then you will see that if you do just after the class, you don't require a separate time to check it again, read it again. It will become permanent in your memory. Save your time. It's very difficult to recall the concepts after 2 months. So it's better, whatever concept we are doing, do the quiz straight away. Don't start doing quizzes from unit 1. Now it's very high time. Whatever you are learning in the class, do the quiz based on that topic which we have done. Don't worry about marks. You can do it twice, thrice. Okay, ready for question, children? Okay, now we are on the questions. Here is the first question. So, Hess's law questions will be of this type. They will give you reactions, like this is reaction 1, delta H naught 1. This is reaction 2, delta H naught 2. And this is reaction 3, delta H naught 3. Three reactions are given. Their enthalpies are given. They are asking, calculate the standard enthalpy of formation of CS2. It means, first, you are going to write down the equation for the formation of CS2 liquid. Ready? Formation reaction for CS2. CS2 liquid. So what are the reactants? Is given, liquid is given. What are the reactants here? I want answer from all of you. We have done how to write the formation reactions. Formation reaction means the formation of the compound from its elements in their standard form. Isabella, what are the reactants? Arana, Ashita, Sanjana, Sarayu. Sarayu was not there in the class at the time. No. Carbon, graphite, not S2. Can you see that, children? These are formation reactions, isn't it? Formation of CO2 from its elements, formation of SO2 from its elements. So pick up from here. This is the standard form of sulfur. Dhruv, you're getting it? Question is giving you hint. So sulfur rhombic. So I'm not writing. There's no need of writing rhombic. It's okay. Carbon, graphite, and sulfur rhombic. Is it balanced? No. So 2 sulfur. Yeah. This is my desired equation, desired reaction. Calculate the enthalpy change for this reaction. So this is the desired reaction. Desired reaction. I want to know delta H naught for this reaction. Delta H, and it's called as formation because it's the formation of CH2. Now I'm going to use these three equations to get this reaction. And what can I do? I can add them, I can subtract them, I can flip them, I can multiply them. I can do any mathematical operation. This is 1, this is 2, this is 3, let's say. Okay, so now what do you want? Where do you want C graphite? On the reactant side? Take equation as such, don't change it. C graphite. Equation 1 is giving me C graphite. Understand this, children. It's one of the simplest concept. It's a fun doing these questions. CO2. I'm taking equation 1 as such. No change. Why? Because I need C graphite on the reactant side. I need only one, and equation 1 is giving me that. So I'll take it as such. I need 2 sulfur. So I'll go for equation 2, this one. But I need 2. So I multiply equation 2 with 2 to get 2 sulfur because I'm in need of 2 sulfur. Plus, now when I multiply 2s plus 2O2, giving you 2SO2. Okay, write on the state of the matter. This is solid. Now what happens to delta H2? It gets multiplied by 2, right? Because I multiplied the whole equation by 2. So this value should get multiplied by 2. You're getting it? See how I'm doing it? I'm looking at C graphite. I'm picking up the equation which is giving me C graphite the way I want. Then I checked sulfur. I need 2 sulfur on the reactant side. I picked up equation 2 multiplied by 2. Now, what else I want? I want CS2 liquid. Which equation is giving you CS2 liquid? Which equation has CS2 liquid? The third. 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 This one. Right? But is it on the reactant side or product side? And where do you want? Come back to your desired equation. Where do you want? Desired equation, I want it on the. So what should I do? I'm going to reverse the equation. Reverse it. 2SO2 gas plus CO. I'm writing it in the reverse manner. See, I'm reversing the equation. So my delta H of the reaction for the third equation will also get a reverse sign. Now delta H naught 3 should be multiplied by minus because I reversed the equation. Correct? So all the 3 equations are here in the plate now with all the desired changes. Add them. Add these equations. See whether you are getting your desired equation. Okay, check 2SO2, 2SO2. Cancelled? Intermediate. CO2, CO2. Cancelled? O2 plus 2O2, 3O2. Cancelled? So what is left? Is there anything to cancel? No. What is left? C graphite plus 2S solid giving you CS2 liquid. And this is your desired equation. See, you are getting your desired equation. But the question is not this. Question is enthalpy of formation. So delta H naught, this is a formation reaction. So I'm going to call it as formation is equal to delta H naught 1, this one, plus 2 times delta H naught 2 minus delta H naught 3. So children, they may ask this question in this format, in the multiple choice form, MCQs, where the answer are written like this. So you should know what you are doing. You should know how to write in this form also. But what is the answer? What's the delta H naught formation value of my desired equation? Plug in the values. Delta H naught 1 is this. I hope all eyes are here on the whiteboard. Because if you miss this understanding, you will miss wonderful questions from your AP exams. Easy, very easy, easy to score. Minus, this is minus, but this is also minus. So minus and add them. Use your calculator, just addition, subtraction, that's it. And you will get your answer for the formation of CS2 liquid. Yes, you first do the changes. You're not adding these equation as such. Are you adding as such? No. Because if you add as such, you will not get your desired equation. So you'll focus on your desired equation. So what are the steps for Hess's law? Write desired equation. First, you write down your desired equation, the reaction on which you are working. Second, do changes in given equations. There will be 3, 4 equations given. So you're going to do changes in given equations, right? And add them. Third, after adding, check. Are you getting desired equation? This is check step. Check for desired equation. Means whatever left should be your desired equation or reaction. And the fourth is change delta H values, change and add delta H naught values of the different equations to get the final, to get delta H naught of the reaction. So these are the steps which we need to follow. So first you are going to write down your desired equation. Sometime it will be given to you. Like in this question, it was not given. And this question is very important question. They have not given the equation. They have given the information. What's the standard enthalpy of formation of CS2? From the definition of formation enthalpies, we decided the equation. We made the equation. So this can happen with you in the exam. They will not give you the desired equation. They will give you information. Then you have to write your desired equation. Then whatever equations are given, do the changes so that when you add them, you should get your desired equation and accordingly change your delta H. Ready for first question? I have to erase everything. Let's see the first question. Okay, this one. Let's do this one. I want answer from all of you. Please, all of you, answer here. So these are the equations given. Mark them as 1, 2, 3. What is this equation? Can I say this is desired? So this is your desired equation because we had to calculate for this. So this question is simple. They have already given you desired equation, right? Now the aim is to do the changes in equation 1, 2, 3 to get the desired equation. So from where can I get this? And what should I do? Yeah, answer all of you, please. Focus on this. Which equation is giving me CLF? Mhm. Which equation is giving me CLF? Equation 1, 2, 3. Dhruv is saying 1. Is he right? Okay. How many CLFs you want? You want, desired. Check how many, what you want. 1. How many this equation is giving you? So what should you do? Do the change. What I'm going to do with this equation 1? Yes, divide it by 2 and write it. CLF divided by 2. So it is CLF now. O2 will become, write down in your notebook, divide the whole equation by 2 and divide this delta H also by 2. Don't worry about anything. Don't start thinking what will happen to this or what will happen to that. Don't look anywhere else. Just keep focusing the way I'm saying. Delta H1, 2. Some children, they start worrying about these things. What will happen to this? What will happen to this? This is not there. As I said, don't worry. Just focus on CLF. So I can get CLF from equation 1 if I divide the whole equation by 2. Now focus on the next thing, F2. Which equation is giving you F2? Mhm. Are you going to take it as such or you need to do some changes? Divide by 2. Let's take equation 3, children, now, because I want F2. One F2 is with 2 F2, so I'll divide it by 2. F2 gas plus 1 by 2 O2 gas, and this F2O will become just F2. 2 F2O will become F2. So delta H3 divided by 2. Now I want this ClF3. Which equation is giving me ClF3? How many ClF3 you want? And you want it on the reactant side or product side? So what you should do with equation 2? Tell me. What should I do with equation 2 so that I get one ClF3 on the product side? Yes, divide by 2 and reverse. So I'm writing it. I'm dividing the whole equation by 2 and reversing. So it becomes 1 by 2 Cl2O plus 3 by 2 F2O, giving you ClF3. Just focus on what you want, okay? Rest of the things will take care on their own. When you add them, you will see rest of the things will cancel out and you'll be left with your desired equation. So what is the operation we have done on delta H2? Minus, because you reverse the equation. So minus delta H2 divided by 2. Right? Now add. Add all these equations to check whether you are getting the desired equation. Add them. So let's cancel the things which are on the product side as well as reactant side. The intermediates, I'm canceling the intermediates. Right? Add these two oxygens, add them. This will become 1 O2. Cancel. Add these F2Os, this one. When you add them, it will become 3 by 2 F2O. Cancel. Right? Is there anything else canceling? No. Write the equation, whatever left. I'm writing the equation now. ClF gas, this one and this one. F2, these are the things which are left, right? Giving you ClF3 gas, this one. Rest all you see cancelled. And this is your desired equation. This is what you wanted. Yes, very good. Sarayu, very good. Now what is delta H reaction? Just add all these values. So in the exam, in free response, they will give you these equations, and then in the multiple choice questions, they will give you options in terms of delta H1, delta H2, delta H3. Like this is the right option. This is the right option, right? But they may give you this option, delta H1 times 2 minus delta H2 divided by 2 plus delta H3 times 2. They will give you one option like this. But you know that this is wrong. So you have to work it like this. You have to see how you are operating your delta H to get the delta H of the reaction. And then you have to pick up the right option from the multiple choice question. So they can write options in terms of enthalpies rather than mathematically. Means they will not give you values. They will simply write H1, H2, H3 like this. Yeah, you're going to add all the equation according to the moles you want in your equation. And you want it on the reactant side or on the product side accordingly. So what's the answer? Plug in the values and you'll get the answer, right? Plug in these values in this equation, final equation. Delta H1 is, and then you can decide whether the reaction is exothermic or endothermic. Delta H3 is this minus, so I'm taking it minus 43.4 divided by 2. Delta H2 is, this is plus, but this is after reversing minus, so minus 341.24 divided by 2. I think this reaction is going to be exothermic. Oh, see, is it negative or positive? I feel that it should be negative because these numbers are big. Yeah, it is negative. It's exothermic. So take care when you're writing the answer, take care plus minus. Okay? Because plus minus will change the word. If it is plus, endothermic. If it is minus, exothermic. So that's a big thermochemistry, exothermic, endothermic, right? So that's about your uh, one of the questions, simplest question in which the desired equation is given. So if you look at the Zundel book, you will see plenty of such questions there, where equations are given. The best thing about this book is that they will write down in the question bank, they are writing Hess's law questions. So just go to that Hess's law topic and check the questions there. Solutions manual will be there. If it is not there, I will definitely going to upload everything today. I think I have to create the question bank also. Okay. Now we are left with very less time. Okay. Isabella is asking where it is. So I'll show you, Isabella. And we have two more important questions to practice, but we don't have time today. So I'm planning to do it again tomorrow. So tomorrow we'll start with the Hess's law again. And those who want to see where are the questions, where are the quizzes, they can stay in the class. And I'll see you then in the next class. Yes. Dhruv, we don't know where you can find the videos. Okay. I'm sharing it, children. One second. I have to close this thing. I'll take only few minutes. Okay. Sharing the screen with you. So you clicked here for the classes. Then this is your group, this one. This is for me. So I have so many groups running. So you can see so many things here, but for you, there is no confusion. This is there. Click on it. Then, can you see this kinetics here? This is unit 5, which we were doing. I think you joined from here today. Here are the videos. Then notes. I have made notes. Like, that's the reason I'm not giving you much time for writing. You see, during the class, I'm asking you to type answer, discuss with me, because I know that notes are already uploaded. So you can write in brief. Okay, see, these are the notes. I'm ensuring these are made by me. Of course, I have taken help of the books, right? So notes are in detail, in depth. Just download them and make a print out, make a book out of it. Okay, now we are actually on this thermodynamics. And you can see the videos. Oh, no, videos are not uploaded. These are not visible to you. So I'll do it today. I think I have to upload 2 or 3 videos here. So then you can see the videos and you can see the notes. And then I'll upload the quiz also. Everything will be there. I'll do it today. Give me some time. And after this class, I'll take rest for 1 hour. And after that, I'll do it. So by your morning or midnight, you can see it. But are you okay that where to see the quizzes? Isabella? Look at this quiz. Oh, this one is not there. Somebody told me. Please, if you are doing the quizzes and if you find some error in the quiz, please do let me know. See, this is the quiz. 10 questions only. Only 10 questions there. Okay. So please start doing them. See you then. Bye bye. If you still have any question, you can stay. Arana?